Hello students, and welcome to another video. I'm your teacher, Mr. Flynn, and today we're going to be working with a new unit called Molarity. Alright, this is referring to how concentrated a solution is. And we're going to be solving two problems. We're going to solve a basic problem, then we'll do one that's a little more complicated. Okay? So in this first problem, we have to calculate the concentration of a 3.5 liter solution. Okay? And it contains 2.7 moles of ethylene glycol or antifreeze. The units for molarity is moles per liter. So if we have 1 liter of substance, how many moles of a substance are in that liter? Okay? And in this instance, we have 3.5 liters, and we have this many moles of it. So all we got to do is just set it up. So our molarity is 2.7 moles of basically antifreeze. All right, and I divide that by 3.5 liters. All right, and to calculate molarity, all I got to do is just divide them. So 2.7 divided by 3.5 gives me a total of 0.77. Big M. So big M is actually equal to moles per liter. So I could also write it like this, moles per liter, like this as well. Either of these would work, but if you want to just shorten it, you can just write big M for moles per liter. So if I were to look at something like I have a you're going to see
Jerry Rivera, you are needed in the gym. Thank you.
Thanks, Sherry. You're now in our video forever. All right, so if you look on the outside of these bottles, these volumetric flasks, let me just tilt this up a little bit more. Okay, you're going to see a solution of copper chloride, and it's 1M. Okay, so this is referring to its concentration, moles per liter. And I made this solution. I know exactly how many atoms are in this, how many grams of copper chloride are in it per liter. And if you look here, this is 0.77 M. So which one's more concentrated, my copper chloride or this antifreeze solution? So if I look here, this 1M is bigger than this. So this actually has more copper chloride in it than the antifreeze in this solution that we've made. Another example here is barium chloride. This one's clear. Okay, it's a little bit easier to see on the camera. And it's 0.1 molar. Okay, so it's going to be much less concentrated than this. All right, but you also need to recognize some solutions and concentrations are going to vary because the substance being dissolved is different. Fruit punch, right? If you're putting in some sugary drink mixed together, right? I don't know what it would take for that to be very sugary and concentrated, right? So when you're looking at these, all we're looking at is how many particles of barium chloride are in here, right? I can't tell you if it's like a strong or weak solution, but I can tell you that it has this much stuff in it, all right? And when you work with it in the lab, specific concentrations are better than others for different experiments. So, yeah, but just overall looking at it, you're counting out how many moles, right, do we have in that solution per liter, right? Okay, let's go down below and let's calculate another problem that's like this. Okay, so let's calculate the concentration of a 100 milliliter solution containing 0.25 moles of NaCl. So our proportion is moles per liter, and that's equal to big M, just as a review. All right. So our top is our moles, so we have 0.25 moles of NaCl. Okay, and our solution contains 100 milliliters of solution. And the problem that we're seeing right off the bat is this is not in liters. This is per milliliter. So what I need to do is convert this into liters. In order to do that, I do my picket fence, and I want to put liters down here because this is the unit I want. And how many milliliters are in a liter? Well, we have 1,000 milliliters per liter. This is going to be a common conversion. You're going to be doing this a lot with your problems. Okay, so when you type in your calculator, okay, 0.25 times 1,000, and then I divide it by 100, and that gives me 2.5. Okay. And if you wanted to, you could have just simply rearranged your units and such, but just teaching you how to type it out because problems always aren't this simple. Okay, so it's 2.5 moles per liter, or you can do big M. All right. So this one is definitely more concentrated than this one. There is more salt in here, like atoms of salt, or compounds of salt, ions of salt in solution than there is of this antifreeze. Actually, it's more concentrated than any of these. It's even more, 2.5 times more concentrated than this copper chloride. Okay. All right. I think that's everything for this video. But the big idea is just understanding that you have to have your proper units of moles per liter. Okay. Thanks again for watching. Until next time.